Hello, good day everyone. Today we will going to discuss about the data management system, which is in chapter 9 of our book. So I am Blessime Aurelio and I am one of the reporters for this chapter. So before we start, let me show you the learning objectives for this module. So we are expected that after this discussion or after we read this module, we are able to understand the operational problems inherent in the flat file approach to data management that gave rise to the database concept. Second, understand the relationship among the defining elements of the database environment. Third, understand the anomalies caused by unnormalized database and the need for data normalization. Fourth, be familiar with the stages in database design, including entity identification, data modeling, constructing the physical database, and preparing user views. And the last one, be familiar with the operational features of distributed databases and recognize the issues that need to be considered in deciding on a particular database configuration. So for the topic 1, which is the overview of the flat file versus database approach, database management system. In chapter 1, database management was already introduced to us. So it is not the first time that we will hear about this topic. The database management system refers to the technology used to optimize and manage the storage and retrieval of data from database. And we also learned the task of data management, which is the storage task, the retrieval task, and deletion. The storage task is assigning keys to new records and restores them in their proper location in the database, while the retrieval task is locating and extracting an existing record from the database for processing. So after processing, the storage task will restore the updated record to its place in the database again. The deletion is the task of permanently removing obsolete or redundant records from the database. We have two general data management approach. The first one is the flat file model. The flat file model or the legacy system, users own their data file or data, and a specific data file was created for each application. While the second approaches is database model, wherein they create a single data repository to support numerous applications. So for us to understand this more, let me show you the difference between the two general data management approaches. So the figure 9-1 shows us the flat file data management. So in here, makikita natin na each user merong sari-sariling program, which is program 1, program 2, and program 3. And every user meron din silang sari-sariling data storage. Nasabi kanina sa definition ng flat file model na each user own their data. So makikita natin dito na si user 1, pag-aari niya yung data A, B, and C. Si user 2, si data X, B, and Y. And user 3 naman is si LB, and M. Na-mention din kanina na each user has their own application. So makikita natin dito na si user 1, sarili niyang application si program 1. Dito din natin makikita na every user, sila lang yung may access sa data nila. So hindi pwedeng ma-access ni user 2 and ni user 3 yung data ni user 1, which is the data A, B, and C. Ganon din naman yung sa data ni user 2, hindi din siya pwedeng i-access ni user 1 and ni user 3. Dun naman sa isang approach which is the database model, na makikita natin sa figure 9-2, here, we have various users also. And every user, meron silang sarili-sariling program. But the difference between the flat file is iisa yung data storage niya or yung pinaglalagyan ng mga data from every user, which is the database. And mapapansin din natin dito na yung data ni user 1, 2, and 3 na nailagay sa iisang database, mapapansin natin na iisa na lang yung data B. So dito makikita natin na kapag napag-isa na yung mga data sa database, wala nang magiging redundant na data since yung database system is kino-collect niya, ini-store niya na ng iisa yung mga data. So as we compare the two, we can now understand their differences. So let's take a look on the problems in the flat file approach, or it could also be the disadvantage in the flat file model. So first is data storage. So in data storage, because excessive storage and it could cost a lot. So as what we see in figure 9-1, every user may sarili-sarili silang program and sarili-sariling data storage, wherein napansin din natin na may mga nauulit na data. And siguro meron ding times na pare-parehas lang din naman sila ng program na ginagamit. Pero since sa flat file na sari-sarili kasi sila ng paggamit ng application and sari-sarili sila ng data storage, kahit pare-parehas yung data, is nagkakaroon pa rin sila ng sari-sariling copy nito. Kasi hindi accessible kay user 1 yung data ni user 2. Example na lang data B kanina, which is redundant na yon kasi meron sa user 1, user 2, and user 3. And alam naman natin na because of this, nagkaka-incur tayo ng mas maraming cost, and syempre na mas madaming storage yung nagagamit nang dahil sa mga redundant na data. The second problem is data updating. Since magkakahiwalay every user or may sarili-sarili silang mga data storage, kapag kailangan mag-update, isa-isa yung pag-update. So changes in addition are performed multiple times. So imagine sa figure 9-2, meron tayong 3 user. So ang pag-update is 3 times kasi they are updated individually. Hindi siya pwedeng i-update as one. And then the third problem is currency of information. Problem of performing multiple updates is the problem of failing to update the files of all users affected by a change. So alam naman natin na sa mga users, since hiwa-hiwalay sila, kapag mag-update, magkakahiwalay din. So for example, may times na accidentally hindi na i-update yung isang file. So ibig sabihin, hindi na current yung file na yon or yung data na yon kasi hindi na siya na-i-update, hindi na siya kagaya ng mga iba na na-update. Example na lang is yung value niya sana. Hindi na naisali na na-i-update, so hindi na din nabago yung value niya, which is hindi dapat mangyari kasi maaapektuhan yung mga data or information na nasa atin. The fourth problem is task data dependency. User's inability to obtain additional information as his or her needs change. So nakita natin kanina and nalaman din natin na hindi accessible kay user 2 and user 3 yung data ni user 1. So for example, kailangan ni user 1 yung data X, which is wala sa data storage niya. And yun is available yung data na yon pero kay user 2. Pero since hindi niya yun pwedeng ma-access, data X is existing but it is not accessible for user 1. Since dun sa data is not available to the other programs, it cannot be obtained because there is no interaction kasi 'di ba kanya-kanya lang sila. So because of these problems, nag-evolve or nabuo ang database approach. So, tignan natin ulit yung figure 9-2. Di ba kanina kasi sa figure 9-1, hiwa-hiwalay yung mga data every user. Pero sa database approach natin, nasa iisang database na lang yung mga data natin. So, here, flat file problems are solved. Data sharing or centralized databases resolve flat file problems. So, yung problema natin kanina sa data storage, na-solve na siya ng database approach. Yung mga data redundancy din natin kanina is already solved. So, no data redundancy. Each data element is stored only once, thereby eliminating data redundancy and reducing storage costs. So, hindi na siya kagaya nung sa flat file approach na meron siyang flat file B for every data storage. Dito sa database, iisa na lang yung data B natin. So, wala nang data redundancy. And then the second one, kanina problema natin sa flat file is multiple times tayong nag-update. But in the database approach, single update na lang siya because each data element exists in only one place. It requires only a single update procedure. This reduces the time and cost for keeping the database current. And then yung current values, a change any user makes to the database yields current data values for all other users. So since iisa na lang yung database natin and isahang update na lang siya, so yung current values is magiging same na dun sa mga nai-update or current na yung mga data natin kasi nai-update na ng isahan. Wala na yung mga naiiwan or yung accidentally na hindi na-update. And then, di ba kanina, problema natin is yung task data dependency. Sa flat file as sa flat file. Pero sa database approach, meron na tayong task data independence wherein users have access to the full domain of data available to the firm. As users' information needs expand beyond their immediate domain, the new needs can be more easily satisfied than under the flat file approach. Only the limitation of the data available to the firm and the legitimacy of their need to access its constraints users. So, because may access na lahat sa data since all firms information is in one storage, ang magiging problema na lang natin is, di ba napag-aralan na natin yung from our past lesson na meron tayong mga information which is sensitive or confidential. So, ang magiging problema natin dito is since meron ng access lahat dun sa mga information sa data storage, magiging problema natin is yung mga information na hindi dapat ma-access ng iba wherein pwede na nilang ma-access dito sa approach na to. Na dahil dyan, meron tayo nung controlling system or yung nagko-control para ma-access yung mga information sa database natin. And that is the database management system. The database management system stands between the user's program and the physical database. So, eto siya. So, yung database management system natin, yung user natin, yung user's program natin, so si program 1, program 2, or program 3, pag may kailangan na data si user 1, so si program magsisend siya ng request for the data that they need dito sa database management system natin. Since si database management system, siya yung nagva-validate or nag-authorize ng access sa database. So bago magkaroon ng access si user 1, 2, or 3, i-validate mo na or i-authorize ni database management system. Since meron tayong mga information na sensitive or confidential na hindi pwedeng i-access ng iba. So the purpose of the database management system is to provide controlled access to the database. The database management system is a special software system that is programmed to know which data elements each user is authorized to access. The user's program sends requests for data to the database management system, which validates and authorizes access to the database in accordance with the user's level of authority. So, last for topic 1 is the 3 conceptual models. So, meron tayong mga common database approach used for business information system. We have the hierarchical, network, and relational model. The hierarchical model is the oldest type of data model. So, sa model na to, ang pag-present ng data is they use tree-like structure. While in the network model naman, it is the advanced version of the hierarchical model wherein ang pag-organize naman or ang pag-present ng data here is they use graphs. While sa relational model, different siya sa hierarchical model and network model because unlike the two, there are no physical links sa pag-present nila ng data because they use table in presenting data. Si Model 1 and 2 natin are termed as navigational or structured model since ang pagprepresent nila ng data is tree-like structure at saka they use graph. So, tinatawag sila navigational or structured model. So, mostly ngayon ang ginagamit or ang system na employ na ngayon is the relational database. Pero the hierarchical model and network model is still existing.
Topic 2. Elements of the database environment. There are 4 primary elements. First, the user. Second, the database system. Third, the database administrator. And fourth, the physical database. Here presents a breakdown of the database environment into 4 primary elements. Shows how the user access the database in 2 ways. The first is via user application programs that system professionals prepare. These programs send data access requests to the database management system, which validates the request and retrieves the data for processing. The method of the database access is via direct query, which requires no formal user programs. The database management system has a built-in query facility that allows authorized users to process data independent of professional programmers. Now discuss the 4 primary elements of the database environment. First, the user. They are the one who access the database. And there are 2 ways to access the database as I mentioned earlier, at via user application programs and via direct query. Primary element of the database environment is the database management system. It provides a controlled environment to assist user access to the database and to efficiently manage the data source. So, database management system have 4 features. First is the program development, contains application development software, backup and recovery, where they make backup copy of the database annually, database usage reporting, it captures statistic on database usage used by the database administrators, help in assigning user authorization and maintaining the database. And fourth is the database access. It is the most important feature because it is able to permit authorized user to access the database. Here's an overview of the database management system operation. So first, the user program sends a request for the data to the database management system, and the call is written in a special data manipulation language that is embedded in the user program. And then the database management system analyzes the request by matching the call data elements against the user view and the conceptual view. And if the data request matches, it is authorized and processing proceeds to step 3. But if this not match the views and the access is denied. So the third one, step 3, is the database management system determines the data structure parameters from the internal view and passes them to the operating system which perform the actual data retrieval. Data structure parameters describe the organization and access method for retrieving the requested data. So step 4, using the appropriate access method, the operating system interacts with the storage device to retrieve the data from the physical database. So step 5 is the operating system then stores the data in the main memory buffer area here managed by the database management system. The database management system transfer the data to the user's work location in main memory. At this point, the user program is free to access and manipulate the data. When processing is complete, step 4, 5, and 6 are reversed to restore the processed data to the database. Now proceed to the data definition language. It is a performing language used to define the physical database to the database management system. It defines database in 3 levels. First, the internal view, wherein it presents the physical arrangement of the records in the database management system. It has only one view. It allows the particular user to describe the structure of the records, linkages between them, and their physical arrangement. The conceptual view or the schema. It represents the database logically and abstractly. It also has only one view. So it allows the user program to call for the data without knowing the data arrangement. And third is the user view or the subschema. It is a portion of the database and it has many views, not like internal view and conceptual view. Let's now proceed to data manipulation language or the DML. It is the proprietary programming language that a particular database management system uses to retrieve, process, and store data. Entire user programs may be written in the data manipulation language or alternatively, selected data manipulation language commands can be inserted into programs that are written in universal language such as PL over 1 or PL over 1, Common Business Oriented Language or COBOL, and Formula Translation or the Fortran. Query language. It permits end user and professional programmers to access data in the database directly without the need for conventional programs. International Business Machines Structured Query Language SQL has emerged as the standard query language. SQL is the fourth generation non-procedural language with many commands that allows user to input, retrieve, and modify data easily. This is an example of a select command used to query an inventory database. So this shows that you can easily get or retrieve the data that you need. Let's now proceed to the third primary element of the database management system. So it is responsible for managing the data source. So there are functions of the database administrator. First is they are responsible for database planning. They develop organization's database strategy, define database environment, define data requirements, develop data dictionary. And then they also are responsible in creating design, logical database or schema, external user views or subschemas, Internal view of the database control. They are also responsible in implementation of what is planned. So they are determine access policy, implement security controls, specify test procedures, establish programming standards, and also in operation and maintenance. They evaluate database performance, reorganize database as user need demand, and retrieve standard and procedures. And also in change and growth, they plan for the change and growth and evaluate new technology. This figure shows the organizational interactions of the database administrator. Importance is the relationship among the database administrators, the end users, and the system professionals of the organizations.
So topic 3 is all about the relational database model. The relational database model, introduced by E.F. Code, originally proposed the principles of the rational model in the 1960s, represents data in the form of two-dimensional table called the customer. Its strength is the ease with which tables may be linked to one another, a major weakness of hierarchical and network databases. It supports the relational algebra functions of restrict, project, and join. So this figure 9-8, it represents a relational table called customer. The relational algebra function restrict, project, and join. Restrict, extract specified rows from a specified table. This operation illustrated in figure 9.9a. It creates a virtual table or one that does not physically exist, or that is a subset of the original table. Project extracts specified attributes or columns from a table to create a virtual table. This is presented in figure 9-9b. Join builds a new physical table from two tables consisting of all concatenated pairs of rows from each table as shown in figure 9-9c. So this is an example of the relational algebra function, restrict, project, and join. This is the example of restrict, project, and join. Data modeling concept. Data modeling concept, it is a visual representation of an organization data. It represents the nature of data and the business rules that dictate how they are used. Data models are designed in top-down approach, which requires a detailed analysis of the organization's information needs. The client's organizational database developers may then modify the model to suit the company's specific needs. This is often called the bottom-up approach. Data modeling concept. The model represents the nature of the data and the business rules that dictate how they are used. A data model is similar to a blueprint or a plan of a house. The blueprint is created by an architect based on the prospective owner's stated requirements. Once approved, the blueprint guides the physical building of the house. Similarly, database developers use the completed data model, often in the form of an entity relationship diagram, to construct the physical database tables and the coding needed to make it function as prescribed. Accountants and auditors work extensively with databases as part of their day-to-day activities, whether preparing financial statements, tagging data attributes, reporting, or extracting financial data from the tables during the conduct of audit tests. Accountants and auditors need to understand how the data are structured. Entity relation, occurrence, and attributes. Entity is anything about which the organization wishes to capture data. Entities may be physical, such as inventories, customers, and employees. They may also be conceptual, such as accounts receivable and accounts payables. Relation describes how data in one entity are related to data in another entity. Occurrence is used to describe the number of items associated with an entity. Attributes are the data elements that define the entity. So this is the data model using an entity relationship diagrams. In this example of an entity relationship diagram, it represents the entity level ER diagram. This is a high-level perspective of the overall schema, which presents only the key entities and the relationships. It does not show the data types and keys contained within the entities. Associations and cardinality. Association describes the nature of the functional connecting between two entities in a relation. It is represented in an ER diagram by a verb label on the connecting lines such as ships, requests, and receives. While the cardinality, it is the degree of association between two entities. The number of possible occurrences is one table that are associated with a single occurrence in a related table. It used to determine primary keys and foreign keys. So this is an example of entity association. Example 1, it is it shows that for each occurrence in the employee entity, there is a possibility of 0 or 1 occurrence in the company car entity. To illustrate, select a single hypothetical occurrence in the employee entity and look toward the company car entity. Only 2 cardinality values are possible. Example 2 illustrates a situation in which each occurrence in one entity is always associated with one and only one occurrence in the associated entity. In this case, each company laptop computer is assigned to only one manager, and every manager is assigned only one computer. Two short lines intersecting the connecting line at both ends depict this cardinality. Example 3 presents the relationship between customer and sales order entities. Notice that the minimum number of sales order occurrences per customer occurrence is 0, and the maximum is many. The cardinality exists because customer is a physical entity that transcends the current accounting period. A customer may have been a customer for years. The sales order entity represents an event that takes place within a period. Therefore, it is possible for a particular customer to have purchased many times this period or not at all, and thus the 0 or many cardinalities. The crow's foot symbol, which gives this form of notation its name, depicts the many or upper cardinalities at the sales order end of the association line. From the perspective of the sales order entity, however, every occurrence or sale is associated with one and only one customer. Example 4 presents a situation in which each specific item of inventory is supplied by one and only one vendor, and each vendor supplies one or many different inventory items to the company. Contrast this association with a similar situation in example 5. Example 5, using the vendor and inventory entities again. Example 5 illustrates a situation where company policy requires a purchasing the same types of inventory from multiple suppliers. Management may do this to ensure that it gets the best prices or to avoid becoming dependent on a single supplier. Under such a policy, each vendor occurrence is associated with one or many inventory occurrences, and each inventory occurrence is associated with one many vendor occurrences. Example 4 and 5 demonstrate how cardinality reflects the business rules in the place within an organization. The database designer must obtain a true understanding of how the client, company, and specific users conduct business to properly design the data model. If the data model is wrong, the resulting database tables will also be wrong. Example 4 and 5 are both valid but different business options, and as well shall see require different database designs. Example 6. The cardinality notation technique shown in example 1 through 5 is called Krauss foot. Several alternative approaches are also used. One method is the explicitly write the upper and lower cardinality on the association line. Another is a shorthand version that notes only upper cardinalities such as 1 to 1, 1 to m, and m to n, as illustrated in this example 6. The physical database table. The physical database model are constructed from the data model with each entity in the model being transformed into a separate physical table. Properly designed tables possesses the following four characteristics. First, the value of at least one attribute in each occurrence or row must be unique. This attribute is the primary key. The values of the other non-key attributes in the row need to be unique. Second, all attribute values in any column must be of the same class. Third, each column in a given table must be uniquely named. However, different tables may contain columns with the same name. And the last one, tables must conform to the rules of normalization. This means they must be free from structural dependencies, including repeating groups, partial dependencies, and transitive dependencies. The physical, the physical database table Figure 9-12 represents the linkages between relational tables. Linkages between relational tables. Logically related tables need to be physically connected to achieve the association described in the data model. This is accomplished by using foreign keys as illustrated in this figure. In this example, the foreign keys are embedded in the related table. For instance, the primary key of the customer table or the cost number is embedded as a foreign key in both the sales invoice and cash receipt table. Similarly, the primary key in the sales invoice table or invoice number is an embedded foreign key in the line item table. Note that the line item table uses a composite primary key composed of invoice number and item num. Both fields are needed to identify each occurrence in the table uniquely, but only the invoice number portion of the key provides the logical link of the sales invoice table. Foreign keys are not always embedded like in this example or in this figure. The degree of cardinality between the related tables determines the method used assigning foreign keys. Relationship between users, views, and entities. A user view was defined earlier as a set of data that a particular user sees. Example of users' views are computers see screens for entering or viewing data. Management reports are source documents such as an invoice and a purchase orders. Views may be digital or hard copy, but in all cases, they derive from underlying database tables. Simple views may be constructed from a single table, while more complex views may require several tables. These simplified tables and views presented in this figure 9-13 illustrates this relationship. Anomalies, structural dependencies, and data normalization. Anomalies are negative operational symptoms caused by improperly normalized table. This section are these anomalies, structural dependencies, and data normalization deals with why database tables need to be normalized. In other words, why is it necessary for the organization database to form an elaborate network of normalization tables linked together like those illustrated in figure 9-12. There are three types of anomalies. First, the private anomaly. Private anomaly is the result of data redundancy in an unnormalized table. The second one, insertion. Insertion anomaly. Insertion anomaly, it demonstrates the effect of the insertion of vendor has entered the marketplace. The organization does not yet purchase from the vendor but may wish to do in the future. The third one would be the deletion anomaly. Deletion anomaly involves the unintentional deletion of data from a table. This one is an example of physical anomaly. Normalizing tables. Normalizing tables, there are three characteristics or topics that would be discussed in this: the repeating groups, partial dependencies, and transitive dependencies. Normalizing tables, relational database. The database anomalies described earlier in the text are symptoms of structural problems within the table called dependencies. The normalization process involves identifying and removing structural dependencies from the tables, being modeled such that the resulting tree and F table designs will meet two conditions. All non-key or data attributes in the table are dependent on or defined by the primary key. The second one, all non-key attributes are independent of the other non-key attributes. The first one, repeating groups, partial dependencies. These are the steps of normalization process. Represents the view as a single table. Represents the view as a single table that contains all the view attributes. This single table that contains all the view attributes presents a single table structure containing the sample data because the table contains customer invoice. The invoice number will serve as a logical primary key. The first step would be the remove repeating group data. The first step in correcting structural dependencies is to determine if the table under review contains repeating groups. The first step in correcting is to determine the table under review contains repeating groups. Repeating groups data occur when multiple values for a particular attribute exist a specific tuple. For example, the sales invoice in this figure contains multiple values for the attributes prod number, description, quantity, and unit price. In this figure 9-19 shows the resulting table. One is called sales invoice table with invoice number as a primary key. The second table contains the transactional detail for the invoice and is called line item table. You will notice that the primary key of the line item table is a composite key, comprises two attributes, invoice number and product number. Keep in mind that this table will contain the transaction details for our example invoice as well as transaction details for the invoices of many thousands of customers. Relational database theory requires that the table primary key uniquely identify each tuple stored in the table. Remove partial dependencies. Remove partial dependencies occurs when one or more non-key attributes are dependent on or defined by only part of the primary key rather than the whole key. So the next one, we need to check to see if the resulting tables contains partial dependencies. A partial dependency, this can occur only if tables that have composite or two or more attributes primary key. In this figure, 9-20 illustrates the partial dependency in it. In this line item table, invoice number and product number together define the quantity sold attribute or quantity. If we assume, however, that the price charged for art R234 is the same for all customers, then the unit price attribute is common to all transactions involved in product R234. Similarly, the attribute name description is common to all transactions. These two attributes are not dependent on the invoice number component of the composite key. Instead, they are defined by product number only and therefore are partially dependent rather than fully dependent on the primary key. We solve this by splitting the table into two, illustrated in this figure 9-20. The resulting line item table is now left with the single non-key attribute quantity. Product description and unit price data are placed in a new table called inventory. Notice that the inventory table will contain additional attributes that do not pertain to this user view. A typical inventory table may contain attributes such as reorder point, quantity on hand, supplier code, and warehouse location. This demonstrates how a single table may be used to support many different users. At this point, but the table 9-20, this figure, are in 3 and F. The line item table primary key are the invoice number, product number, wholly defines the attribute quantity. Similarly, in the inventory table, the description and unit price attribute are wholly defined by the primary key product number. The next one would be the remove transitive dependencies. A transmittive dependency occurs in a table where non-key attributes are dependent on another non-key attribute and independent of the table primary key. The removed transitive dependency is the final step in resolving a structural dependencies to remove the transitive dependencies. An example of this is illustrated by the sales invoice table in this figure 9-21. The primary key invoice number uniquely and fully defines the economic event, the order date, shipping date, and the shipping via attribute represents the key does not, however, uniquely define the customer's attributes. The attributes customer name, street address, and so on define an entity customers for that is independent of the specific transaction captured by a particular invoice record. Linking the normalized table. Figure 9-22 represents the linkages between normalized table. The table contains the sample data used in the original single table structure. You will notice how data redundancy in the original single table structure has been eliminated from the more efficient structure represented here. This requires first determining the cardinality between the tables and then assigning foreign keys. Determine cardinality. Keys in 1-to-1 cardinality, keys in 1-to-m cardinality, and keys in m-to-m cardinality. Keys in 1-to-1 cardinality, where a true 1-to-1 cardinality exists between tables, either or both primary keys may be embedded as a foreign key in the related table. On the other hand, when the lower cardinality value on one side of the relation is 0, 1-to-1, 1-1-to-0-1, a more efficient table structure can be achieved by placing the one side table's primary key in the 0 or 1 or 0, 1 table as a foreign key. Using the employee or company car example in figure 9-11, we see the importance of this key assignment rule. Imagine reversing the rule by placing the company car 01 side table primary key into the employee 11 side table. Since most employees are not assigned a company car, then most of the foreign keys in the employee table will have null or blank values. While this approach would work, it could cause technical problems during table searches. Correctly applying the key assignment rule solve this problem because all company car occurrences will have an employee assigned and no null values will occur in the foreign keys. Keys in 1-to-m cardinality, where a 1-to-m cardinality both 1-1-to-0m and 1-1-to-1m exists, the primary key of the one side is embedded in the table of the m side. This figure 9-23, applying the 1-to-m key assignment rule, illustrates this with an example and some samples database. On example 4 in figure 9-11. In this example, a vendor supplies many different types of inventory, but each type of inventory is supplied only by one vendor. The one-side primary key or the supplier name, now supplier number is embedded in the M-side inventory table as a foreign key. Keys in cardinality. An M to M relationship is presented in this figure 9-24, which is based on the inventory status report shown in figure 9-14. In this situation, the business rule specified that each vendor supplies the firm with many inventory items, and each item may be supplied by many different vendors.
Topic 4, the top-down approach to designing relational databases. View modeling determines the associations between entities and document them with entity relationship diagram. Next. So, view modeling begins by identifying the relevant views of the business function in questions. Dito nakapaloob yung mga user interviews and other techniques. Dito malalaman kung anong gagawin ng mga users at kung anong informations ang kailangan nila to support their task. Next. Next step is to determine the cardinality between entities and linked entities with foreign keys. Dito naman, pagsasamahin lahat ng mga data na kailangan ng mga user into single schema para maging organized. This step, which is deconstruct the physical database, is about creating the physical tables and populate them with data. Dito, wait here. Prepare the physical user views. Dito, gumagamit ang mga database developers ng SQL or Structured Query Language para malaman kung anong klase ng table ang gagamitin at kung anong column para makagawa ng mga user views. Usually, report program ang ginagamit para mas madaling mabasa ito. Next. Last step naman ang commercial database system. Commercial systems, dito naman mas nagbe-base sila sa mga best practices para mas satisfy yung mga needs ng iba't ibang client organizations. Developers can thus focus on configuring predefined views to accommodate specific user needs within their organizations rather than starting from scratch.
So for topic 5, which is the databases in a distributed environment. Distributed databases are databases distributed using either the partitioned or replicated technique. The distributed databases is reorganizing the IT function into small information processing unit or the IPUs that are distributed to end users and placed under their control. An important consideration in planning a distributed system is the location of the organization's database. So, di ba meron tayong dalawa, the distributed databases and the centralized. So, the centralized database is a database retained in a central location. Data currency in the distributed data processing environment. So data currency is when a firm's data files accurately reflect the effects of its transaction, while the temporary inconsistency occurs during accounting transactions. Account balances pass through a state where the values are incorrectly stated. So kabaliktaran siya ng data currency. The database lockout is a software control that prevents multiple simultaneous accesses to the data. So, yung software control na to is usually ginagamit siya sa database management system. So, nag-occur ito in the distributed data processing with centralized database. So, para hindi ma-access multiple times, meron tayo ng database lockout. Kasi 'di ba sa distributed ang mga data is nai-distribute siya. So, para hindi sabay-sabay na magamit, meron tayo ng database lockout na tinatawag. So, for distribution way ng distributed data processing na mention kanina na meron tayong dalawa. We have the partitioned and the replicated. So, the partitioned database is a database approach that splits the central database into segments or partitions that are distributed to their primary users. So, i-distribute yung mga database na by part, ganun. So, every segment siya compared sa replicated mamaya. So, ang deadlock is a wait state that occurs between sites when data are locked by multiple sites that are waiting for a removal of the locks from the other sites. So, di ba kanina ang database lockout is ginagamit siya para hindi ma-access multiple times. So, if sabay-sabay na nag-lock yung mga data, yung mga or ng multiple sites, magkakaroon tayo ng deadlock. So, sa deadlock phenomenon, mailalak yung mga database. And it is a problem in the partition. So, it occurs under the partition database. For this to be for this problem para maayos is meron tayong certain software na ginagamit. Merong mga software na ginagamit yung mga firm para maayos itong deadlock phenomenon. Next. So, yung isa naman, yung pangalawa sa partition is the replicated databases. So, replicated databases is a database approach in which the central database is replicated at each site. So, kung kanina, yun dun sa partition is nahati siya by part. Ito namang sa replicated is na nagkaroon ng replication. So, etong replicated databases is para rin siya sa data sharing. So, kaya ni-replicate yung mga data. The concurrency control is a system that ensures the transaction process at each site are accurately reflected in the database at all other sites. So, di ba, sa distributed, so, hiwalay na yung mga data natin, ganon. Meron tayo nung concurrency control, which is, ito yung nag-check nung mga sites natin sa mga database, yung mga data, kung accurate ba yung mga data. Kasi 'di ba, kapag in-update, may mga times na, kagaya kanina na dun sa currency problem natin. So, ang concurrency control, sila yung nag-check para malaman yung mga infos or yung mga information kapag nag-update, and yung concurrency control din, sila din pwede din gamitin yung na-check nilang yun kung sinong user yung nag-update. So in the future, kung magkakaroon ng problema, malalaman nila kung sino yung mga kung anong user ba yung nag-update if ever na problem arises. So that's all for chapter 9. Thank you for listening.